two projects. In this video, we are going to explain the project Deep Learning in Cervical Cancer Diagnosis, Architecture Opportunities and Open Research Challenges. Introduction. The project aims to harness the power of deep learning, a subset of artificial intelligence and machine learning, to transform the landscape of cervical cancer diagnosis. Cervical cancer, a prevalent and often fatal disease, presents a global health challenge. So, the project involves the development and refinement of deep learning algorithms tailored for cervical cancer diagnosis. By integrating state of the art image processing techniques, the aim is to enhance the accuracy of computer aided diagnosis, that is, CAD systems. Cervical cancer, characterized by the uncontrolled division of abnormal cells in a woman's cervix, can be effectively addressed with early detection. The utilization of deep learning technology holds the promise of providing timely and accurate diagnosis critical for effective treatment and support. Cervical cancer is a formidable global health concern, particularly affecting women in developing countries. Current diagnostic methods such as pap smear screening and colposcopy face limitations, including dependence on scarce specialized professionals. The project addresses these challenges by proposing advanced deep learning based solutions that offer improved accuracy and efficiency, specifically targeting early stage cervical cancer detection. Early detection is crucial for successful treatment, making this project a vital step towards reducing the impact of cervical cancer on women's health worldwide. And the primary beneficiaries of this project are women globally, especially those in low income countries where access to specialized healthcare resources is limited. By improving the efficiency and accuracy of cervical cancer diagnosis, the project aims to reduce morbidity and mortality rates. Additionally, healthcare professionals, particularly in regions facing a shortage of specialized doctors, stand to benefit from more effective diagnostic tools, facilitating timely interventions and personalized therapy for patients. And the inclusion of deep learning technology in cervical cancer diagnosis represents a pivotal step toward addressing a pressing global health issue. Objective of the project. So, as I mentioned earlier, this project focuses on developing an efficient deep learning model dedicated to the automatic segmentation of cervical cytology and colposcopy images. The primary objective is to significantly enhance the accuracy and early detection capabilities for cervical cancer, particularly in its precancerous stages. And the project takes a comprehensive approach to evaluate the developed deep learning model against traditional classification methods such as SVM, KNN, Bayesian network, decision tree, and MLP. And various deep learning architectures, CNN, DenseNet exception, are built. The objective is to identify the most effective combination of techniques. Subsequently, the project aims to propose a holistic solution that optimally utilizes these technologies, emphasizing improved early detection rates and a consequent reduction in mortality associated with cervical cancer. And by creating a deep learning based solution, the project strives to make early detection of cervical cancer more accessible, particularly in less developed countries where the majority of cervical cancer related fatalities occur. The objective is not only to develop a powerful diagnostic tool but also to ensure its practicality and affordability, contributing to a reduction in mortality rates associated with cervical cancer worldwide. Requirements needed to execute this project are software requirements. Software needed is Anaconda. Primary language used is Python. Front-end framework used is Flask. Backend framework used is Jupyter Notebook. Database used is SQLite 3. And front-end technologies used are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements needed are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Now we'll discuss the working modules of law of work. So the first step is important required packages. So in this initial step, essential Python packages such as NumPy, Pandas, Matplotlib, Sklearn, TensorFlow, and Keras are imported to facilitate the subsequent data exploration, image pre-processing, model training, and building processes. These packages provide necessary functionalities for handling data implementing machine learning algorithms, and creating a user interface. The second step is exploring the dataset. So, the dataset comprises two components: cervical cancer images and CC RoboFlow data. So, exploratory data analysis is conducted to understand the characteristics and structure of the dataset, providing insights into the distribution and features of the images. The third step is image pre processing. So, utilizing the image data generator, a popular tool in deep learning, images undergo pre processing. This involves rescaling, shear transformation, zooming, horizontal flipping, and reshaping. And torch vision based processing specifically caters to detection requirements, preparing the images for subsequent model training. The next step is training and building the models. So, various models are trained and built, including convolutional neural networks, dense net, and exception for feature extraction. And for each architecture, the project explores support vector machine, k nearest neighbors, Bayesian network, decision tree, multi-layer perceptron, and a voting classifier as an extension, allowing for an extensive comparison of model performance. And in the next step, as an extension to the project, detection models such as YOLO V5 and YOLO V8 are developed. These models are specifically designed to identify and locate objects within images, contributing to the overall versatility and functionality of the project. And the project extends its functionality with the implementation of a Flask framework that incorporates SQLite for user authentication. So, this front end development allows users to sign up and sign in, providing a secure and personalized environment for utilizing the developed models. So, after signing in, users give input in the form of images. The input undergoes pre processing as per the established procedures, and trained models, both classification and detection, are then employed to analyze the pre processed images, extracting valuable information from the dataset. And the final outcome, encompassing classification and detection results, is displayed through the front end developed using Flask. This user friendly interface provides a seamless experience for users, offering insights derived from the trained models in a comprehensible format. Now we'll understand about the algorithms used. So, feature extraction is a crucial step in image processing where meaningful information is extracted from images to facilitate effective model training. In this project, three powerful deep learning architectures are employed for feature extraction. They are convolutional neural network, densenet, and exception. So, CNN is a widely used deep learning architecture for image analysis. It comprises convolutional layers that automatically learn hierarchical features from input images. Convolutional operations, pooling layers, and fully connected layers collectively enable CNNs to identify patterns and spatial relationships within images, making them well suited for image classification tasks. And DenseNet, or densely connected convolutional networks, introduces a dense connectivity pattern where each layer receives direct input from all preceding layers. This architecture fosters feature reuse, enabling more efficient parameter usage and better gradient flow. Dense net's interconnected structure enhances feature propagation, making it effective for feature extraction in complex images. And exception, an extension of the inception architecture, focuses on extreme depth-wise separable convolutions. This approach significantly reduces the number of parameters while maintaining high accuracy. Exception excels in capturing intricate features within images, making it suitable for tasks where detailed feature extraction is crucial. And for the classification task, several traditional machine learning algorithms are employed. And the first one is SVM, that is support vector machine. So, SVM is a powerful algorithm for both classification and regression tasks. It works by finding the optimal hyperplane that best separates different classes in the feature space. The next algorithm built is KNN, that is K nearest neighbors. So KNN is a non-parametric algorithm that classifies objects based on the majority class of their K nearest neighbors. It is effective for its simplicity and flexibility. The next one is Bayesian network. So this probabilistic graphical model represents the relationships among variables using a cyclic graph. So Bayesian networks are useful for capturing dependencies in complex datasets. The next one is decision tree. So decision trees are a tree-like model where decisions are made based on feature values at each node. They are interpretable and effective for classification tasks. The next algorithm built is MLP, that is multi-layer perceptron. So MLP is a type of neural network with multiple layers of nodes or neurons. It is a versatile architecture suitable for various tasks including classification. Now we'll see the detection algorithms. So for the detection task, YOLO V5 and YOLO V8 are employed. So YOLO, that is you only look once. So YOLO V5 is an object detection model that divides an image into a grid and predicts bounding boxes and class probabilities for each grid cell. It is known for its speed and accuracy, making it suitable for real time applications. And YOLO V8 is an extension of the YOLO architecture incorporating advancements for improved accuracy. It excels in detecting objects within images with high precision. Now we'll see the comparison graphs. So first we'll see the comparison graphs of the algorithms built for feature extraction. So this is the accuracy scores comparison graph. In this graph on x-axis I have accuracy scores and on y-axis I have algorithm names. So accuracy measures the overall correctness of predictions, showing the percentage of correctly classified instances. This is precision scores comparison graph. In this graph on x-axis I have precision scores and on y-axis I have algorithm names. So precision measures the accuracy of positive predictions, indicating how many predicted positives were actually correct. This is recall scores comparison graph. In this graph on x-axis I have recall scores and on y-axis I have algorithm names. So recall measures the ability to identify all relevant instances, showing how many actual positives were correctly predicted. And this is F1 scores comparison graph. In this graph on x-axis I have F1 scores and on y-axis I have algorithm names. So F1 score combines precision and recall into a single metric, balancing accuracy and completeness in predictions. So here we are comparing the performance metrics of the algorithms built for feature extraction. So these are the comparison graphs of the algorithms built for classification task. So these are the comparison graphs of the algorithms built for detection task. This is the MAP scores comparison graph. In this graph on x-axis I have MAP scores and on y-axis I have algorithm names. So MAP, that is mean average precision, evaluates object detection performance by calculating the average precision for each class and then determining the mean over all classes. So the algorithm that is best performing in all the performance metrics will be used for detections. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. These are the folders in which I have required dataset on which we will train the models. This is sample folder in which I have images on which we will make the classifications and detections. This is static folder. This folder consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. And these are model files which contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. This is Jupyter source file for classification and this is a Jupyter source file for detection task. So Jupyter source file contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. So now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open Anaconda prompt. So now use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, The Flask framework will host the application locally at the default address, local host, and port unless configured differently. So this is the local host and this is the port. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up link, click on it. So if we are new users, we have to register first. Fill in all these details and click on sign up button to register. If we already have an account, we can directly log in by clicking on this link. So as I already have an account, I'm clicking on this link. So here we have to provide our credentials, username and password, and click on sign in button. So it has redirected us to the detection page. So here we can see a prediction link, click on it. So as I mentioned earlier, we can perform both classification and detection tasks in this project. So first we'll perform the classification task, click on it. So here we have to upload any colposcopic image and the application will classify the image. Click on choose file button. So here we have to upload an image. So I'm uploading the first one and click on open. The image is loaded. Now click on upload button. This is the uploaded image and here we can see the prediction that is type 1. So the application has detected the cancer and it has classified the cancer type as type 1. Click on try again link. We'll try giving another image. Click on choose file button. So this time I'm uploading this one and click on open. The image is loaded. Now click on upload button. So for this image it has predicted it as type 3. So similarly we can upload any image and can get the classifications. Click on try again link. Click on choose file button. So I'm uploading this one and click on open. The image is loaded. Now click on upload button. This is the uploaded image and here we can see the prediction that is type 1. Click on try again link. Click on choose file button. I'm giving this image this time and click on open. The image is loaded. Now click on upload button. So here we can see the prediction that is type 2. So for this image it has predicted the type as type 2. Now we'll perform detection task. Click on prediction link and click on detection link. So we have to upload any colposcopic image again. Click on choose file button. So I'm uploading this one and click on open. The image is loaded. Now click on upload button. So here we can see the application has detected the disease. It has drawn a bounding box around the disease and it has classified the disease as type 1. And we can also see a probability score here telling us how confident the application is about the detection. Click on back. We'll try again giving another image. Click on choose file button. So this time I'm giving this image and click on open. So the image is loaded. Now click on upload button. So we can see the application has detected the cancer. It has drawn a bounding box around the disease. And we can also see the classification that is type 3. And we can also see the probability score here telling us the confidence level of the detection. So similarly, we can upload any image and can get the detections. Click on back and click on sign out. So the conclusion here is the project successfully integrates advanced deep learning architectures including CNN, DenseNet, and Exception, showcasing their effectiveness in feature extraction for cervical cancer image analysis. This innovative technological integration serves as a foundation for accurate and efficient detection and classification. The comprehensive model training involving traditional classification algorithms SVM, KNN, Bayesian network, decision tree, MLP, And modern detection models YOLA V5 and YOLA V8 enables a holistic approach to cervical cancer diagnosis. This diverse ensemble ensures versatility and robust performance across varied aspects of image analysis. And the implementation of a user friendly front end using the Flask framework, coupled with user authentication through SQLite, enhances the project's accessibility and security. This front end facilitates seamless interactions, making the models available to users for testing while ensuring a secure user experience. And the project extends its reach to less developed countries where cervical cancer related fatalities are prominent. By prioritizing practicality and affordability, the deep learning based solution offers accessible early detection, contributing to a global reduction in mortality rates associated with cervical cancer. So, the final outcomes derived from the trained models demonstrate versatility and accuracy. Through both classification and detection, the project provides valuable insights into cervical cancer, offering a comprehensive solution for improved early detection and contributing to advancements in medical image analysis.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.